everyone, have a nice day and welcome to Abstract Algebra. This day, we will answering 4 questions that related to this subject. So these are the following questions. What are necessary conditions to be satisfied for a set to be a group under a binary operation? What is a subgroup? When a subgroup is called cyclic, how to show that a group is cyclic, and solving or give an example of permutations group. So we will answer the first questions about what are necessary conditions to be satisfied a set to be a group under a binary conditions and illustrate one example. So a group is a set with an operations that has the following 4 properties. These are the 4 properties. The set is closed under the operation. The second property is the set is associative under the operation. Third property is the set has an identity element under the operations that is also an element of the set. And last property is every element of the set has an inverse under the operations that is also an element of the set. So, I will indicate an example on the screen so you can watch that in the screen. So as you can see on the screen, that is the example, so as you can see on the screen, that is the example of a group under a binary operations so that to satisfy for all conditions. Let's proceed to our second question. What is a subgroup? A subgroup is a group that is nested within a larger group. The subgroup test is used to evaluate whether or not subsets of a group are subgroups. A valid subgroup does not contain all of the numbers of the original group, whereas a trivial subgroup only contains the identity that makes the subgroup. So I hope it will make sense. In our third question that we need to answer that our audience will satisfy for this, I hope it will. Our third question is, when a subgroup is called cyclic? A group of G is called cyclic if there is an element, A is an element of J, such that the cyclic subgroup generated by A is the entire group of J. In other words, as you can see on the screen, that is the notations of subgroup is called cyclic, or when a subgroup is called cyclic. So if I will read that notation, J is a set of A to the power of, as you can see on the screen, if I will read that notation, J is a set of A to the power of N such that N is an element of all integers numbers. Such an element A is called a generator of J. Take note that a cyclic group is abelian. On the other hand, a group that is abelian is not necessarily cyclic. I hope it will make sense for you. So to our last question, not the last, there's another last which is the 5. So in giving an example of permutations group. So this fourth question is to try to ask is how to show that a group is cyclic. Example, a finite group is a cyclic. There is an if and only if it has a precisely one subgroup of its divisor of its order. So if you find two subgroups of the same order, then the group not cyclic. Out that can help sometimes. I know that a cyclic group must have a generator which can generate all of the elements within the group. If there is no generator, then you cannot show or you can emphasize that is a cyclic group, because you can only that the cyclic or a cyclic because you know the cyclic is a system that it is a one process repeating again and again. So that is the meaning of cyclic. Therefore, we can only say that the cyclic group if there is a generator on it. So I hope you will satisfied with my answers. If not, then okay. So in our last question, which is we will give an example about the permutations group. So as you can see on the screen,